All right, so let's finish up section 1.6, and in this topic we're going to be adding and subtracting rational expressions. So how does this work? Well, if we relate it to something you're already familiar with, which is adding and subtracting fractions, assume we have 2/7 subtracted 3/5. Well, remember when we're adding and subtracting, the only time we can ever do it is if we have like terms, right? And so these two terms, the 2/7 and the 3/5, are not like terms because they do not have common denominators. So we need to find common denominators. And because these are both prime numbers, right, they're not going to have any multiples to share. And so when two numbers are prime, the least common multiple is going to be the product of the two numbers. So in this case, that's going to be 7 times 5. Okay, and if we had a 7 here, we multiplied 5 to it, so we have to multiply 5 to the top, right? And then we multiplied 7 to the bottom term, so we have to multiply 7 to the top. And so what do we get? Well, 2 times 5 is 10. Our denominator is 35. 3 times 7 is 21. Denominator 35 again. And when we add and subtract fractions and we already have common denominators, the denominator stays the same, and we just do the operation to the top. So 10 minus 21, that's going to be negative 11 over 35. And so what does the polynomial version look like? Well, assume we have 3 over x plus 5, and we're subtracting 1 over x minus 3. And so you should be able to look at these fractions and say, are they like terms? No, they're not, because they have different denominators, right? We need a common denominator. Well, what is this denominator? Well, we can think of it as the binomial x plus 5, and the denominator here is x minus 3. So if we want to have the same denominator, this one, right, this is going to need the x minus 3 term, and this fraction is going to need the x plus 5 term. And so the same kind of idea when we multiplied, one of them by 5 and the other one by 7, it's going to work in the same way. So if we multiply x minus 3 to the bottom, we need to multiply it to the top. And likewise, we multiplied x plus 5 over here to the denominator, so we're going to need to multiply that to the top. Luckily, on the top, we only have a 1, so anything times 1 is just itself. Okay, and now you can see we do have common denominators. Let's go ahead and distribute this, simplify this guy a little bit. So we're going to get 3x minus 9 over, and rather than writing the denominator the same, I'm just going to put 2 lines. That just means the denominator hasn't changed since the last time I wrote it. Right, and we still have the x plus 5. Okay, and then now we have this binomial minus this one. 3x minus x, right, is going to be 2x. Negative 9 minus 5 is going to be negative 14. And all over x minus 3, x plus 5. And if we wanted to, we could rewrite this as 2 times x minus 7 over x minus 3, x plus 5. Now, you can stop at either of these 2 places. At least at the beginning of this section, you definitely can. Typically, the only reason we'd ever factor something like this is assume, if we had one of these as x minus 7, if we factored it this way, then we'd be able to cancel it because we could see that that's a factor. But since nothing is going to cancel out, either of these is acceptable for now. All right, and let's get to the last topic of this section, which is simplifying complex rational expressions. So, simplifying complex rational expressions. Okay. And so how does this relate to the reals? Well, it's a technique we went over not too long ago. Assume we had 2 plus 1 half over 3/5. So what do we mean by complex rational expressions? We basically mean fractions on top of fractions, right? And so you can think of this as one fraction, and we're dividing by another one. So why don't we change this to a fraction instead of dividing by a fraction, right? We could think of this as that, but we don't like dividing fractions, right? We like multiplying by reciprocals. But notice here, this is a binomial. Now 2 plus 1/2. We could add these together, but first we need common denominators, right? So we need a 2 on the bottom here. And if we multiply a 2 on the bottom, we have to multiply 2 on the top. Let me just do that in another step. So first, let's get a common denominator here. So do a little bit of the work over here. 2 over 1 is a fraction, and since we need a denominator of 2, we need to multiply the bottom by 2. If we do that, we need to multiply the top by 2, and so we get 4 over 2. Okay, and so we can rewrite this as 4 over 2 plus 1/2 times 5/3. And so now that we have common denominators over here, we can add these together. 5 over 2 times 5/3. And what do we get? Well, we get 25 over 5. And that simplifies into 25 divided by 5, which is just 5. Okay, so let's do that instead with polynomials. And so what does that look like? Well, assume we have the problem 2 plus 1 over x all over x over 2. And so this works the same way. We can write this as 2 plus 1 over x divided by x plus 2. But we don't like dividing by fractions, so we're going to multiply by fractions instead. And so we can flip the second fraction to be 2 over x, right? And so if we want to add these together first, we just have to find the common denominator. So we'll do the work on the side again. We have 2, but we, instead of having a denominator of 1, right, 2 is 2 over 1, we want a denominator of x. So we need to multiply x on the bottom, and if we multiply an x on the bottom, we need to multiply x on the top, so we get 2x over x, and that's 2 with the denominator of x. So that's going to look like this. Right, and so now we have common denominators, so we have 2x plus 1 over x and times 2. And since these are just multiplying fractions, we can just multiply top to top, bottom to bottom. 2 times 2x is 4x. Right, this is the rainbow method. 2 times 1 is 2. And then x times x is x squared. All right, and that's simplifying this rational expression. So it essentially works the same way as we do with fractions, but just involve variables. Hopefully that made sense. And I'll see you in the next section. We'll be moving on to section 2.2, linear equations in one variable.